One final concept we're going to look at in lab this week is the concept of, or the concept of using capacitors to filter out signals. And by that, we're going to talk about a voltage here, or a signal, that consists of two components. It has a DC component, just a battery that is not time varying, and then added to it is going to be a time varying sinusoidal voltage. In lab, we're going to use about a 4.1 kilohertz signal. So we have then, if you were to graph this out, we would have up here at our 5 volt DC, we'd have a constant component to it. And then oscillating around that would be a 5 volt peak voltage oscillating also. So instead of the sinusoid, instead of this thing oscillating around V equals 0, it's been lifted up by a 5 volt DC amount, and it's now oscillating around plus or minus 5 volts, well, around 5 volts, and it's going up 5 volts to 10 volts or down 5 volts to 0 volts. Now, we're not going to go into a lot of the details as to how this works, but when you place a resistor and a capacitor in series with each other and look at the voltage across the capacitor, this circuit has the interesting characteristic of removing the oscillating part and allowing just the DC component to be seen across this capacitor. In other words, in this part of the circuit, the voltage across the capacitor is just going to be the 5 volts DC. There'll be a little bit of oscillation in it, but not a lot. And we'll be able to hook the oscilloscope up, and we'll look at that voltage across here. In fact, we're going to use all 3 channels. We're going to look at the voltage across, not all 3, because there's 4 channels on our oscilloscope. We're going to use 3 channels. The first channel will be looking at across the source, where we have the 5 volts with a 5 volt DC offset. Channel 2, we're going to look just at the voltage across the capacitor, and what we're going to see is that just the 5 volt source is seen. The oscillating component has effectively been removed from this. Now on this side, once again, we've got a resistor and a capacitor, but this time the resistor is tied to ground, and we're going to be looking at the voltage across the resistor. And what we're going to see in this instance is that the DC component has been removed by the capacitor. And all we'll see here, or at least substantially all we're going to see here, is that 5 volt oscillating signal. So if originally it was offset up here 5 volts and going up to 10 and down to 5, here we're going to see it very close to 0, oscillating up and down 5 volts. Oscillating 5 volts above and below 0. In other words, we can filter out the DC component with this circuit, and we can filter out the sinusoidally varying or the higher frequency component with this circuit, and this is what we're going to refer to as filtering. The concept of filtering is a very important one. If you stop and think about it, in the airwaves, all radio signals exist. All the television channels, at least all the broadcast television channels, all the broadcast radio channels are there, radar are present, cell phone signals are present. And it's this concept of filtering that allows us to tune the television or radio or our cell phone to a specific channel and allow only that channel to be heard, and effectively removing or filtering out all of the other signals that are present. So this concept of filtering we'll be talking about throughout much of your electrical engineering education career. It's a very important and very useful concept made possible through, at least in its most simple form, through the use of resistance and capacitance.